Let me have your attention, please. Let's begin. Let me have your attention. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker. But before I introduce today's speaker, I need to make some comments. In particular, we have a very distinguished guest with us today, all the way from Shanghai University in Shanghai, China. Namely, it's Dr. Wei Zhou, and he is the Vice President of Shanghai University. And Dr. Zhou, would you stand up and let's express our appreciation for him. Secondly, those of you that attend our weekly colloquium presentations, you recognize today that we are, what's the proper terminology? We've taken a step up, hopefully, in the technology that we use to present to these presentations each week. Namely, the university has some specialists in making webcasts, and they've been doing this on a regular basis, and their equipment is much better, much more expensive than our equipment. Plus, there's 3 of them here today, where normally we just have our own Gary Graves as the technician who puts this, makes this broadcast happen. And so this is really an experiment for us today, and we'd appreciate any feedback that you in the local audience and also the cyber audience you may have about what we can do better or do differently to make these broadcasts better. And now for today's presentation, the speaker is Mr. Lee Hoke, who is he was the TV electrical design manager for Philips Consumer Electronics Company. He's retired from that position. Mr. Hoke received a BS in electrical engineering from the University of Pennsylvania in 1956 and an MS in electrical engineering also from the University of Pennsylvania in 1966. He's been in the TV business with the Philips Company or its predecessor since 1960. He retired in the year 2000 after 40 years of service with the company, and he was their lead TV designer. He built his first TV when he was 13 years old in 1948, and he used the old green and white 3-inch oscilloscope screen. Okay, that was the picture that he built his first TV when he was 13. The most important factor is that he is a good friend of mine, a golfing buddy, and we really enjoy each other's company. And so without any further delay, ladies and gentlemen, please welcome Mr. Lee Hoke.
Thank you, Dr. Dodds. The thrust of this presentation today is to help us understand what kind of hardware and what kind of decisions we're going to be faced with when the TV stations which we were so accustomed to viewing go dark at the end of 2006. They will be replaced with their digital counterparts. However, many of our current receivers will also go dark. So the presentation will talk about these issues. It is more a consumer-based presentation rather than a technical-based presentation. So I'm not going to wow you with a lot of formulas and charts. We're going to deal with things that we would want to know about as a potential consumer for a television set. Analog to digital, that's the transition that we're faced with. Here are some analog telephones. Some of you recognize them. And here are their newer digital counterparts, the wireless as well as the cell phone. Those are all digital products. Analog signals usually have a smooth curve, and they're much like what's coming off of a phonograph record. It's an exact replica of the sound and analog television presents a signal that's an exact replica of the scene, whereas digital is going to be discrete pieces of energy. It's going to be on or off. And also digital can be represented as a series of numbers. So you can convert a digital signal into a series of numbers as compared to an analog signal. Speech or music in analog, you would hear the word C or the letter C. You recognize it. Does anyone have any idea of a very old digital equivalent? Morse code. It's been around a long time. That is a digital signal. It's on or off. Okay, so digital is not really so new to us. Encoding. So we're going to convert life as we have known it into a series of numbers or a series of discrete pieces of energy. Now, why is digital TV coming around? Well, analog black and white dates back to World War II. And color was added to the signal in 1953. So it's old. Technology moves on. That's why all the students are here, to help push technology. Nearly all the other household electronics that you're familiar with are currently digital. Here's some historical dates to look at. In '82, the Advanced Television Systems Committee was formed, and it was interested in high-definition television, done by any means. Over the next 10 years, there were quite a few proposals made, many of them analog proposals, some of them trying to be compatible with the current television signal and trying to extend the resolution or extend the picture information. In 1993, it was realized by these 5 companies that the direction that the industry and the business was going was not going to achieve anything. So they joined together and formed the Grand Alliance, and within a year and a half, they were able to produce the digital TV standard, which is now on the books and which is what all the stations are converting to. The agreement that they came up with was that it should be digital, although some of the original members of the Grand Alliance had very big analog signal processing techniques for doing high definition. But it boiled down to a digital signal. November 1998, the 10 largest markets began to broadcast. So we've had digital television on the market now for 8 years in some areas. And here's a map showing those areas in red. The East Coast, you have Boston, New York, Philadelphia, Washington. In the South, Atlanta, Detroit, Chicago, Los Angeles, and San Francisco. Those are the 10 largest markets that began broadcasting in '98. By late '99, we had the first digital broadcast here in Knoxville. Channel 6 went on the air with a small transmitter. And in 2006, all the over-the-air stations will be broadcasting only digital signals. They will turn off their analog broadcast transmitters. The bureaucracy of the whole thing is that the Congress gave the Federal Communications Commission the power to do spectrum recovery, which has always been a big issue. There simply is not a sufficient amount of radio frequency spectrum for all the things that are coming on the market. And so the FCC has decided that television should be forced into channels 7 through 51, and the other channels 2 through 6 and 52 through 69 should be abandoned, and that will happen in 2006. Now, the sale of these abandoned channels will be by lottery. These frequencies will be sold to other services, safety, mobile phone, others, and the result will be big bucks for the U.S. Treasury. So Congress is always interested in hearing how we can bring money back into the Treasury. Here's the lineup of our Knoxville stations. The present channels are listed, and over on the far right, the new channels. And notice that all the channels in Knoxville will be UHF stations in 2006. Several of these stations are on the air currently, and you can receive them during prime time. Now, there must be some advantages to digital, otherwise we wouldn't be doing it. A noise-free picture. Those of you who have switched over to satellite have been enjoying a very noise-free picture. That's a digital transmission. Those of you who are still using a rooftop antenna and trying to get the broadcast station from the other side of town, the further you get away, the noisier that picture gets, the more snow. Digital will give you a broadcast noise-free picture. It will give you higher detail in the same channel space. It will give you a widescreen movie format. That's the new structure of the signal. Will be widescreen. Here's an example of widescreen. 16 by 9 are the parameters for the new picture. And if you superimpose a 4 by 3 box on there, you can see that some of my friends would have been lost from this photograph under a 4 by 3 scenario. The other way, which we see now on our television sets, you get black bars at the top and bottom when they're transmitting a widescreen picture. They're trying to accommodate it into a 4 by 3 raster ratio. Here's an example of the 4 by 3 picture superimposed on a 16 by 9 picture, and both have the same diagonal dimensions. And you can see that the 4 by 3 actually has larger picture area, but that's not an issue. The issue is widescreen, movie-like. And that's why 16 by 9 has been pushed as the format. The fourth advantage is that multiple programs can be broadcast within the television channel. So a broadcaster can choose with his 6 megahertz television channel to give you one high-definition program, or he can choose to send you 4 standard definition programs. And in that case, you will be tuning to channel 32A or 32B or 32C or 32D. And the new receivers will have this capability of selecting the sub-channels within a television channel. So this is a capability, and these standard definition programs are the same resolution that we currently have with our analog. With the digital signal, there is far less interference between stations. The digital signals do not cause the problem that our current analog stations cause, to the extent that one must now position stations far enough away so that people living halfway between don't really have a problem, that you can get a clear station one way or the other. However, with the digital signal, with less interference, naturally, one can put those channels, the same channel, those stations closer together and pack the area with fewer channel spectrum. And that has also allowed this spectrum shrinkage that the FCC is performing. So we should see less interference between our stations over the air. The new digital television signal will have greatly improved sound, 5.1 channels. And here's the room layout for a 5.1 channel system. You have the left speaker, center speaker, right speaker, left rear, right rear, and then the subwoofer up by the TV set, which you get your bass, your boom boom from it. So that's 5.1 channels, and that's how you would set up your room for the new system. It's not all good. There's some bad. Some disadvantages. The big one is that the signals are not compatible with the existing population of receivers. All of us that have a receiver that's more than a month old have a problem with the digital signal. The receiver simply will not handle it. And so you're going to need a set-top box to adapt the older sets. Now there are three types of digital already in existence. There's digital cable, digital satellite, and digital over the air. Those three signals are not compatible with each other. Each one was developed by a different group of people with a different goal in mind, and oftentimes looking at the other guy and saying, you guys made a terrible mistake, we're doing it the right way. So you've got a situation like this. This is what has been existing. Three separate standards for the digital signals. As time goes along, this problem is being corrected throughout the system. And we'll talk about that later. The reception area for digital is limited by a phenomenon called the brick wall or the waterfall. And here's a chart to demonstrate that. In the analog signal, as you move away from the station, the signal goes from clear to snowy to weak, and until finally till there's no signal left. But you can live out in here and watch some television, albeit snowy. With the digital signal, the reception is clear and good all the way to this brick wall, to this corner, and then it falls off. And that fall off could be only a matter of a quarter of a mile or so. If you try to use rabbit ears in your house for a digital signal, you may find that the rabbit ears pick up a signal in this corner of the room. When you move the rabbit ears to the other corner of the room, no signal. So with digital, you either have a signal, a good picture, or you have no signal, no picture. It's not a snowy issue the way analog is. So the fifth disadvantage requires a roof antenna to receive the over-the-air broadcasts. And most of the channels, all the channels in Knoxville, are going to be on UHF. Now we're going to shift gears and go to another part of the television technology and learn some issues which will then play back into our digital television a little bit later on. How does the TV set create the picture? Well, here's a side view of a picture tube. Old-fashioned technology has been around since 1900. These things were invented a long time ago. You have an electron beam that's being generated in the back of the tube and sent through a set of deflection coils to the front, and then it scans this area of the front of the tube, which contains a phosphorescent coating, and where the beam hits the coating, it lights it up. So you have the beam to create a television picture scanning across that coating and creating that picture. If you have gotten up close to your TV set, you see the scan lines, and that's the work of that electron beam on the phosphorescent coating. We have two kinds of scanning in television. We have interlaced scanning and progressive scanning. And we'll spend a minute talking about that. With interlaced scanning, the beam scans a portion of a line and then skips a line and does the third one, and then skips and then does the fifth one, etc. And then at the bottom it comes back and scans the ones that it had missed. So it does evens, a full raster, and then odds, a full raster. And so the current televisions that you've been watching are all interlaced scan. It scans even lines and then odd lines. And this picture is a 60th of a second. It overlays this picture on it for a 60th of a second. So the full picture lasts for a 30th of a second. And you haven't noticed the flicker. So that's interlaced scanning. Odd lines are scanned, then even lines are scanned, or vice versa. So with progressive scanning, lines are scanned sequentially. It starts at the top and scans each line 1 through 480 and then back to 1 and sequentially like that. Computers are progressively scanned. Now the question always comes up, well, if you have two techniques, one of them has to be better than the other. Well, one is better than the other for some things. But for other pictures, it flips over the other way. Progressive scanning is better for computer-generated pictures. Interlaced scanning has been around since the 40s, and it really handles motion pictures, moving pictures, and still pictures much better than progressive scan. But progressive scan takes up more bandwidth, requires more channel space for its picture than does interlaced scanning. And that's why interlaced was selected back in the 40s for the current television system. So that's a scanned picture. Now we're going to talk about pixels, pixelated pictures, discrete pictures, segmented pictures, if you will, made up of small individual blocks. And this would be an LCD type picture or a plasma, a DLP or an LCOS. Some of our newer picture display technologies use individual small blocks of display. And the total number of blocks in the picture is equal to the product of the horizontal number times the vertical number. Let's go to this one. There are several formats for digital television. This was one of the areas where several companies could not agree with each other as to what it should be exactly, so the FCC accepted a multiple format, hoping that sooner or later the public would buy this and not buy that, and the decision would be made at the marketplace, one of our famous marketplace decisions. Standard definition, we showed 4 standard definition channels within one television channel. Here are the parameters for that. 740 lines by 480, 740 pixels by 480 pixels, and it's interlaced scanned, 4:3 aspect ratio, and the pixel count is 338,000 pixels. Another standard, how can you have multiple standards? Another standard, the enhanced definition, has the same number of pixels, but it can be 16:9, and it can be progressively scanned. Some manufacturers we're liking that as a definition. Then there are 2 high-definition standards, 1280 by 720 progressive, 16 by 9, for almost a million pixels, 922,000. And the second high definition, which is the highest definition, 1920 by 1080 interlaced, 16 by 9 for 2 million pixels. And just in case you wondered what our old analog system that we've strained our eyes all these years watching, here it is, 450 by 480, about 216,000 pixels. So even the standard is going to be somewhat better than our current analog system. Okay, the next topic to talk about is what size TV set should I buy if I'm going to want high definition, and how far should I sit from the high definition TV set? Yes. And we get asked these questions all the time. In fact, everybody skips the first part and they come right to this, and then I have to explain some of the first part to them. Here's a chart of viewing distance for a high definition picture. This is a 1920 by 1080 picture. We have across the bottom the picture size in diagonal inches and viewing distance in feet. And we have two curves in there, one with the purple one representing someone who has average visual acuity, 1 millimeter, and 0.5 millimeter visual acuity, better than average eyesight, a younger person perhaps. And you can see that for a given distance or a given screen size, you would have to sit for a 40-inch television set, you would have to sit about 6 feet away from it with average eyes. This is in order to see the total picture resolution that's available. Yeah, you can sit further away from it, you just don't appreciate all the money you've paid for the set. You're just not seeing all the resolution that's there. So this chart often boggles people, and they think about it for a while, and questions after the presentation that I've given in the past, it's all on this subject. So think about it and get your questions ready. Standard definition, what we've had on the air all these years, you wonder why you can sit 20 feet away and you don't see anything more than if you sit 5 feet away. Well, here's standard definition. For a 30-inch size, 18 feet is about as much as you're going to see, because standard definition doesn't have the detail in it. So you can sit further away and get your money's worth. Now we're going to do a little experiment. Here's where we get technical. What size will the high definition picture be to give us an eye chart E at the TV's smallest resolution? So we're going to take 16 by 9 high definition picture. We're going to put a 2020 E in the middle of it, and we're going to view it from 20 feet. Brought my eye chart along. This is an accurate Snellen chart, and we're going to take the E from this line with the red line under it. That is 6 meters, or it's about 20 feet. We're going to take an E from that line, put it on our TV set with the smallest geometry that we can make with the pixels that we're given. So here's how we're going to make that E. It's going to be 5 pixels tall. So we're going to have a pixel here. Whoops, back one. Going to have a pixel here, a blank pixel, another pixel, 5 pixels high on that screen. And the total picture height will be 1080 pixels. Here we restructure the question again, make sure that everybody has all the information. The E is going to be 8.866 millimeters, or 3/8 of an inch tall on the picture. And what size would that screen have to be able to read that at 20 feet? And the answer is a height of 75.4 inches, or a diagonal of 12.6 feet. A huge picture. That's the kind of resolution that's available with high-definition television. Now, if that doesn't make an impression on you, I've got the experiment going the other direction. Okay, let's assume a 50-inch diagonal. That's about this size. And we're going to put that 5-pixel E on a 50-inch diagonal. And what distance should we be away from that screen to be able to see that E with normal corrected 20/20 vision? If you get further away, the E is a blob. It's not an E. The answer to that comes out to be 7 feet for 20/20 vision. "50 inches, we come back to 7 feet. Confirms that chart. That chart and that experiment were done totally independently with different sets of numbers, and they converge right to the same point. As everybody always questions, oh, where'd you get your information? That chart can't possibly be correct. But we've proven it 2 different ways. Okay, now that you've been schooled in picture size and distance, we're going to look at what type sets are available on the market. And this part of the presentation changes almost monthly. I updated it this week after having made this presentation about 2 weeks ago, and when I was giving it, I thought, gee, I saw something new in the Sunday paper. I better change a couple of slides. So this part of it gets updated periodically. How do you hook them up? Well, we have standard analog sets. They're still on the market. They're going to be there until they finally sell all of them off. They'll be dropping the prices on them pretty shortly. It'll be a real bargain. You've got an NTSC tuner, which is a current standard tuner, analog tuner, and some jacks on some sets. The second level is HD ready. HD ready means that the picture and the screen size are capable of producing a high definition picture, but it does not have a digital tuner in it, and so it can't receive a digital signal. You would have to receive the digital signal some other way and then feed the video information into it. So it's really a monitor. An HD ready can be considered as an HD monitor, although it has a standard tuner, so you could buy it today and receive all the stations today, but not the digital ones. The third level is HD built-in. This has an over-the-air digital tuner. It also has a standard tuner, typically, to receive today's stations, and it has video jacks on the back, so it's kind of a monitor and television set, and that will give you full feature. That will give you full HD today, as well as tonight when the digital signals go on the air, and well past 2006. And then there's the latest twist, which is an HD TV set, full capability, with a cable card slot in the back of the set. Excuse me. If you are on cable, some of the programs some of the channels are scrambled, and you don't get those channels unless you pay extra. Well, the cable card would be the item that you would pay extra for down at the cable office, plug it into your set, and then you would have full capability for using their signals. You would not need a set-top box to do the translation. So it would be, the ultimate solution would be the HD built-in with the cable card. Eventually, all TVs will have digital tuners. 36-inch and above after July 1st, 2005. Manufacturers must have digital tuners in the sets. That doesn't mean that every set on the retail floor is going to have a digital tuner, but you ought to be able to work a deal. They'll be wanting to get rid of those that don't, the retailers. But after 2005, all sets built must have digital tuners. 25 to 35, they get another year. 13 to 14 to 24, these are the kitchen countertop sets. They have until 2007 to get those fully digital tuner capable. And VCRs, DVDs, and all the rest of the stuff, that peripheral stuff, also has until July 1st, 2007 for the manufacturers to fully incorporate digital tuners. Now, this was an FCC act that was passed back in 2003, and not much has been said about it for the last year and a half. It was hoped that, well, the manufacturers were hoping that if everybody stayed quiet, it would go away. That's not going to go away. So there are the dates. Now let's look at some popular TV sets and compare the technology and the pricing. Here are the picture tube sets, 30-inch to 36, and prices on $600 to $1,500. These are the ones with the big old heavy glass picture tube in. Takes you and a buddy to carry it into the house. Here are the liquid crystal sets. These get pretty pricey. This is the latest pricing. I just got this out of the Sunday paper this past week. That used to be a higher number. That $3,500 was some higher 6 months ago, but those prices have come down. And here's the plasma panel, the picture on the wall sets, the 3-inch thick, and they're running from $2,000 to $7,000. Now you have to be careful with plasma panels. There are a lot of those that are not HD capable. They are have fewer pixels than the 720 by than the 1020 by 780 that is the minimum HD spec. And so plasma panels, if you go shopping for those, the ones at $2,000 probably are not HD. The ones at $7,000 are probably HD. So you have to be careful with that. This is now let's look at rear projection. This kind of technology. Okay, 42 to 65 inch. Here the prices are lower than they were for some of the direct view sets, so you can get a bigger picture using a projection set. And the technology in projection is to have 3 tubes in the box, a red tube, a green tube, and a blue tube, projecting respective pictures, which then bounce off a mirror and all converge on the front of the screen. I'm sure you've all seen it. In fact, this is a projection set using the 3-tube technology. Technology has been around 20 years. It's well known. You can't improve it much more. It's pretty well tweaked. LCD, liquid crystal projection, uses a different technology. It uses one lamp and some beam splitting mirrors, 3 LCDs, a red LCD, a green picture LCD, and a blue picture LCD, and then recombines all of the light, projects it through one lens onto the screen. This technology gives you a rather small projection box, rather small picture box, and so the whole size of the set can be reduced considerably. DMD or DLP, digital light processor, You can see that these prices are higher than the LCD. This is a more recent technology than LCD. And the technology here, again, is one lamp, a color wheel, one DMD element. It's a semiconductor memory type device. It's very small, about a ½ inch on a side. And you bounce the light onto it and then project it out through this lens. The green picture occurs when the green is in front here. The signal to the DMD is the green information. Then this rotates, the blue comes up, blue light, and the picture then is the picture on the DMD is the blue information and transmits it out. This technology was invented by TI about 10 or 12 years ago, and we at Philips were working with them back in the early stages. It sort of gave up. TI would come running in with the latest device. They'd made a whole bunch of them, but one worked. They'd come in and demonstrate it, and we'd look at it and say, okay, we need 5,000 of them. And they go, oh no, we were afraid of that. They'd already made 5,000. They got one that worked. So it has taken about 10 years to perfect the process so that they now get a good enough yield and they have devices that are sufficiently high quality that it's on the market. It is the new technology. It appears that it's going to be one of two technologies that last in this area. I think the picture tubes are going to go, and it'll be DLP and LCD will be the two technologies that remain. Here's a comparison of cabinet size for projection TVs. The big box is for the CRT type projection. Those tubes are about this big each. So you've got 3 of them and then 3 lenses and mirrors. Whereas that light box for an LCD or a DMD is only about 8 inches square. So the box can be much smaller for LCD and DLP technology. Then another technology for high definition is, of course, front projection or home theater, in which you have a projector shining onto a screen. You turn the lights out and hand out the popcorn and get your picture. It's always interesting to see whether anybody knows where this picture was taken. Okay. Peggy's Cove, Nova Scotia. If you ever go traveling in Nova Scotia, you've got to go to Peggy's Cove. It's a neat place. Okay, let's talk about adapting TV sets for the new signal. Suppose we just bought a set, the old one conked out. Now what do we do? We have our new signal coming in here and a digital receiver playing into our analog TV set. The digital receiver takes the functions of channel tuning and digital to analog conversion. So the signal going to the analog set is an analog. It could be channel 3, you know, the way a VCR gets hooked up to a TV set. So that's one solution. This is the front picture and a rear picture of a digital receiver. And you can see on the back of it, you have an input and then several combinations of outputs depending on how you want to use the receiver and what level of capability your TV set happens to be. If it's just an old-fashioned set, then you would come out of here and go into your TV on channel 3. If it's a digital ready, if it's an HD ready set, which is a monitor, you would take these 3 component, red, green, blue component video signals and patch those in and get a high definition picture that way. Of course, audio for our 5.1. Here's a component set or an HD ready monitor hooked up with the 3 wires for the 3 component video drives. HDTV via satellite. We've got 3 providers. The one on the bottom, Voom, is relatively new and it's difficult to find out much about it. I can't say any more than that. I've tried looking at them on the internet, and their advertisement is a little bit spacey, so I'm not sure whether they're really in business or they're not really in business. Then there was an article in the newspaper in the financial section about a week ago that they have been bought by somebody else, and so I didn't recognize any of the names of the companies, and so I'm not sure whether Voom is in business this week or not. But DirecTV and Dish Network have been around for several years. They're live. DirecTV says, we have an HD receiver that you can lease. There's a programming package for $11 per month, and we'll give you the local HD channels and also a place that you can connect your over-the-air antenna to the box and patch it through. Dish Network says they have an HD receiver, a program package at $10 a month, and the local HD channels, the latest I've got on that is they will provide the local HD channels through their box. So they are on, they're uplinking to the satellite and back down in HD format. Voom advertises 39 HD channels. The research that I've been able to do, I cannot figure out what 39 channels are in HD at this point. I mean, how many showtimes and movie channels can you have to be in HD? Via cable, we have Charter, which takes care of the county, Comcast, which is Knoxville City. Charter has an HD receiver and a DVR. We'll talk about that later. And a cable card is being developed. And HD not yet available in our area. At least 2 months ago, the gal told me they don't have HD yet for the western end of Knox County, Farragut area. Comcast has 8 channels of HD, and a DVR is available, set-top box. So that's satellite and cable. And let's talk about this DVR. This is an interesting kind of machine. Many names for it on the marketplace. TiVo, may have heard of that one. MaxiBox, one of the cable companies calls it that. DirecTV DVR, ShowShifter, and Replay TV. It's the digital equivalent of a VCR. However, there are no tapes to put in it. There are no discs to put in it. It's got a huge hard drive. And we'll look at some of the features of a DVR. It's a set-top box to begin with, so it is a digital receiver. It has outputs for analog, SDTV, and HDTV. So you can use this as your primary feed to your old-fashioned TV or your HD monitor. It has a dedicated computer built in with a large hard disk drive. 2 tuners, so you can monitor 2 stations simultaneously, watch one and record the other. I saw an ad for Sony that had 8 tuners. 8 tuners. Watch one, record 7 channels. I don't know.
There's always a Gulf channel.
This is getting away from me. You can record, some say 30, some are up to 100 hours of continuous TV programs. That's more than you can put on VCR. It's programmable for both time and station, so you can set it up for your program, go on vacation for a month, come back, and all your popular shows will be there. Will be on the hard disk drive. And then you can eliminate all the commercials and away you go. And the neatest feature of it is it records the last 60 minutes ongoing of TV. So while you're watching and it's automatically recording, and if you suddenly decide that you missed something, you missed the phone number or you missed the ad or somebody distracted you and you missed the real key to the show, you can punch the button, go back, replay that, get a delayed replay, and then either continue running the show a minute late, since you took up a minute to do that, go back and look, run it a minute late and just continue to watch until the end of the show. You don't miss anything. Or you can jump ahead and pick it up in real time. Absolutely fascinating gadget. Okay, in summary, if you already have a TV set, and here's what you should do. If you are, and we're going to talk about over-the-air broadcast, satellite, and cable. If you now get your TV over the air, get yourself a good UHF antenna, buy a digital receiver, buy a new digital TV set, whichever. If you get your TV set via cable, what should you do? Do nothing. Cable may continue to provide a basic program in analog. They've got the capability to do that, and they might just do it. Then you can upgrade to a digital package and use their digital cable box. Well, you can do that now. You can subscribe to the 100+ channels of digital and music and buy and rent the cable box. Or you can upgrade to an HD box or a DVR or one of those other, or get a digital TV that's cable capable, HD ready, and HD, full HD and cable compatible. And if you get your signal via satellite, again, you don't need to do anything because it's already digital. Their satellite box does the conversion for you and will continue to. And if you want to upgrade to a DVR or a satellite HD box, you can do that. Okay.
We have time for a few questions. We have time for a few questions, comments. Okay.
2006 is only about a year away, and there are going to be a lot of very, very angry people who find their analog sets require them to buy another box. The portable TVs don't work anymore. Is that going to be a firm, hard date? I hope.
Yes, December 31st, 2006 is a firm hard date. The only way that would get changed is if the Congress of the U.S. decides to counteract their earlier mandate. They gave the FCC the right and privilege to do it, and the FCC did it. Now, it can be turned off, and people have been hoping that it would be, but actually the penetration of digital has gone further now than the forecasts by the industry gurus who said, oh, this won't happen. You know, we'll just sit back like crows on the wire and watch it. But it is happening. It definitely is happening. Knoxville got their stations on the air quicker than any of us imagined. And knowing the cost, it's about $2 million per station to switch over to digital. They did it.
John, you have a question?
Yeah, well, in 2006, all the stations are going to switch over to digital broadcast. That doesn't mean that they're all going to be broadcasting.
Wait a minute.
Let
me give you
yeah.
the mic.
Well, what I'm trying to ask is that all the stations will be forced to broadcast digitally, and that they will not necessarily be broadcasting higher definition.
That's correct.
What we're going for here is to try to get people to buy TVs in high definition that support the high definition quality. Now, what will be the increase in program supply in the high definition, the 1080i or 720p? Who's going to be? Is there going to be more broadcasting in it in 2006, or will it be the same as now? There'll just be more, standard digital that's at 480i or 420p, or.
Yeah, I'm sure that during the day, many of your programs will be in standard. The soaps, the programs in which they don't really want to spend a lot of money in production costs. But then prime time, Well, prime time now, the 3 stations in Knoxville that are on digital, I think all 3 go HD and prime time, and especially on weekends. And then you also see providers like ESPN, who is typically standard during most of the day, and when the really big event comes on Friday evening or Saturday evening or Sunday afternoon, the football games, they switch over to digital. So the trend is more toward HD, but I think you're correct in assuming that it's not going to be totally HD.
All right. Reese?
Yeah.
Has the industry made the digital equipment any easier to operate than, say, the analog equipment, or will we all have to hire a teenager?
Gee, I hope not. I hope not.
I had a question. The high definition cameras, most of them are 16:9 in the screen size. Do they have any high definition cameras and high definition signals that are 4:3? Or is it all 16:9?
I think it's all been switched over to 16:9.
Okay.
Yeah. There was one point that I said I was going to cover later and I didn't cover, so I needed to say it now. Where I was showing that slide with the 3 different digital signals, cable, over the air, and satellite. And I said there is a convergence taking place. What is happening is there's been some work between the cable consortium and the broadcast group led by CEA in Washington, which is kind of a broadcast manufacturing group. And they're trying to converge the specifications to the point that compatibility can be built into the receiver so that you can buy a receiver and either receive over the air or receive cable digital, and the receiver would not take any extra boxes and bells and whistles external. And that's what really makes the cable card a possibility. We now have available technology in the receiver industry to build the receiver that'll pick up both signals and process them equally. So that convergence, those two are converging together. The only issue that's still up for grabs is the one having to do with content protection, content security. Everybody's worried about, well, the digital is so good that, boy, I can record my own and sell it, and they're still wrestling with how do we prevent people from making their own DVDs and marketing them, black marketing all the Hollywood shows on homemade DVDs that have the same quality as the original. So that's still being wrestled with.
Question.
Did you imply that the cable companies can't continue to broadcast analog?
The cable companies can continue to broadcast, convert to analog if they wish. There's nothing anywhere in any of the legal issues that prevent them from doing that. And they may do that beyond 2006. I can't get a clear answer from any of the cable people I've talked to. They simply don't want to discuss it. But technology-wise, they've got the capability of doing it. They're doing it now. They're taking a digital signal off satellite, converting it to analog, and filling up 50 channels of analog for west end of Knoxville. Comcast's got 50 channels of analog. Those are not analog signals originally, except for the 5 TV stations from downtown. All the rest come to them on digital satellites, so they know how to do it. Do they want to market it that way? I don't know, but the technology says it's possible.
Okay, one final question. Do you have a high-definition TV set, and what did you buy? If the answer is yes.
No, I do not have a high-definition TV set.
Okay. How many people in the audience have high-definition TV sets?
How about high definition ready?
HD ready?
Yeah, HD ready. That was sufficient. Yeah. Anything that has the high. So, John, you got one. You got one, and I have one. I have a little one though. I can't afford a big one. Any other questions or comments?
This is about satellite TV.
Who do you dislike most? Technically, 6 of one, half dozen of the other. Cable to the curb now is mostly fiber, and the cable signal to the home is, in most parts of Knox County and Knox City, it's pretty good. It's pretty noise-free. Not like it was 5-6 years ago, but it's pretty good now. So it's who are you mad paying the monthly bill to, and you want to go to the other guy? You know, you think, oh, he's $2 cheaper. You know, maybe I'll make the switch.
Okay, I think with that final comment, we should probably conclude the presentation today. But I do see, as usual, we have several new people in the audience, and you probably don't know, but we have a reception downstairs on the second floor, and the speaker will be down there to answer more questions and make more comments, and everyone is invited. But before we adjourn, let's express our appreciation again to Mr. Hoke for his presentation.
Thank you. Thank you.